Okay, all right. Let me leave what I can leave out and go to the. So, what I just wanted to show you is a small picture of what's happened second after second on the internet, and that's what I wanted to project before I start my speech. But anyway, that's okay, let me leave it out. So today I'm going to talk about big data and its contribution to humanity. We are living in a world that is almost driven by data. We are in a world of a deluge of data. So, what is big data? If you are familiar into technology, you watch about technology and listen on news in technology, you may have already come across with the word big data. So, don't mind. I think you are hearing me. Yes. Yeah. So, my aim this morning is, what is big data? So one of my intentions is that at the end of this presentation, you will be able to define at least what big data is about. Why is it important for me to speak about big data to you? Why? So I want you also to learn why is big data important for you. What are the things, what are the contributions of big data to humanity? The contributions of big data for businesses is obvious. And if you go over the internet, this is one of the big things now happening in technology. So data, big data. Some little quotes about data or big data in general. Maybe you have already heard this. In God we trust, all other things bring data. So which means that in this world, to justify something, you need to bring data. Data is what will help us to rely on whatever you are saying, to back up whatever you are saying. It's very important. And I want to thank the SPS, especially the team, they are carrying out right now some data about health of Adventists in Africa. Generally in Africa, we lack data. We lack data of many things. And this initiative is going to have a good contribution. It is even said that data is a new oil. Data is vital in industry today. Ronald Coase also said, torture the data and it will confess to anything. What does it mean? It means that data have to be processed very carefully. You cannot handle them anyhow, but if you handle them anyhow, you will get conclusions that are not relevant at all. Torture the data and it will confess to anything. Where there is data smoke, there is business fire. So which means in business, data today is vital. That's Thomas Redman that says it. And then let me consider this last one. It is better to use data even with errors without not using data at all. So this really tells us the importance of data in the modern world. So what is it? And especially what is big data? There is no single accepted definition of big data, but let me consider among the many ways we can define what big data is. I will consider 3 of those ways. The first one, as the name suggests, big data implies big volume, that is large size. So though there is no, this is not a conventional, it is not completely accepted, but when the size of the data is already counted in hundreds of terabytes, then we say the data is big. It's classified as big data. So the size. The second way to define big data is to define big data as a size of data that cannot be handled by traditional computing systems. So if you take your traditional data processing or online transaction processing systems and they cannot handle a volume of data, it will be classified as big data. The last one, which is the most important definition of big data, is not necessary to say what big data is, but what are the properties, what are the characteristics of big data. So there are many characteristics. You can put them 8, you can put them 5, but I want to restrain myself to 3. The 3 big. So big data is characterized by what we call 3 V's. The 3 V's. The 3 V's are volume, as we have already said, velocity, and variety. So these are the 3 properties that we will use to define what big data is about. Let me start with the volume. So the volume means the size, which we have already given in the first 2 definitions. So one of the key driving factors of what we call today big data is digitalization. Digitalization is the capacity of put information into digital form. So if you look at the history of the global information storage capacity, you will see, this is what this figure is picturing. So you will see that in 1996, among the all available data in the world, 1% was digital and 99% was analog. By 2002 is a critical date. It's called the beginning of the digital age. Because in 2002, we were able to reach the level of 50%. So among all the data available, 50% were digital and then the 50% analog. Then, by 2007, 94% of the data available is digital. So this digitalization is the key driving factor that's led to what now we call today big data. Still about the volume. So when you look at the volume in terms of big data, let me give you an idea so that you can picture out when we say byte, terabyte, petabyte, or zettabyte, or yottabyte, they may not speak too much to you. But here, this is what you can say. A byte is the memory size that is necessary to store one character, one letter, like ABC. That is, we call it a byte. So if you take, for example, 1 page of text, it will amount approximately 30,000, that is 30 kilobytes. That is a whole book. If you take a whole book, let's say, let me take a whole book can go to up to 1 megabyte, for example. Then, if you take a song, it can be stored in 5 megabytes, and so on. If you take 6 million books, you can put them in 1 terabyte disk. And so on. If you consider the NSA data center, all the data that is gathered in that data center is about 1 yottabyte. So it gives you a kind of idea in terms of size when we say bytes, what it translates into a real world thing. So with that in mind, it is estimated that from the beginning of the world up to 2005, the amount of data that were produced amount for 130 exabytes. If you take the life of one person and you record it as a video from your birth to your death, I would not say 70 years approximation, then it will hold just in 1 terabyte the life of a person. So with those things in mind, now, in 2010 alone, 1,200 exabytes were generated. You can count how many times. So the data that is generated only in 2010 is how many times more than what was generated from the beginning up to 2005. You can do the computation. In 2013 alone, it is 7,900 exabytes and so on. It is estimated by in 2020 alone will generate 40,000 exabytes. So you can see the world is just driven by data. The amount of information that is generated is so big. So that was the volume, and you can imagine. Then velocity. What is velocity? Velocity means speed. So what is the speed of big data? Big data is different from other data. Velocity. Every minute on the internet, there is 201 million emails that are sent. Every minute. Every minute, there is 2.8 million social media posts. Every minute, there are 57,000 pictures that are posted on the internet. So all this, the speed at which data is generated is too high. Very high. That is velocity. Then the next one is variety. The data are varied. Big data are varied in terms of type, in terms of form, and in terms of sources. In terms of type, you can have text, audio, video, and so on, images. In forms, the data could be structured, unstructured, or semi-structured. In terms of sources, there are various sources where the data is coming from. They are coming from the internet, what we call the Internet of Things, devices that are connected, your smartphones, CCTV cameras all out throughout the world. You have the internet itself, the web. So the sources of data are also varied. So this leads to this situation. It has led to what we call the birth of data science. The amount of data that is generated is beyond the capacity, the processing capacity of the current technology. So when we say big data, one way of defining it is, as you can see in this figure, you can say that the amount of data that the humans and the computers right now can handle is quite linear. You can see it is a straight line, it's linear. Whereas when you look at the total available data, it's quite exponential. Then you can see the gap between what we can handle and the actual size. So that gaps define what we also call the big data. So there is a birth of a new science that should come in to help how to deal with this big data. How can we make insight of this big data? How can we make the maximum profit of this big data? If we go by the current technology, we cannot make fully use of this data available. So where the big data science is coming in. So what is data science? Briefly stated, data science is that new area that is coming so that we can exploit all this huge amount of data, new techniques that will involve a multidisciplinary disciplines. Computer science is involved, mathematics and statistics will be involved, and then domain expertise. The data are in various domains, and for you to make use of data, domain expertise should be there. If you have financial data, to make sense of the financial data, you need to have insight about finance. So a domain expertise. So when you take computer science and the domain expertise without statistics and mathematics, it's called traditional software development. If you take computer science and mathematics without the domain expertise, you are doing machine learning. So you can apply what we call artificial intelligence on data, and do what we call machine learning. But when you put computer science, mathematics, and statistics, and domain expertise all together, then you get to what we call data science. So data science is a new discipline that has given birth so that we can address the issue of big data. So why should big data be of interest to us? Well, first of all, you are part of the big data. You are part of the big data. Each time you use your phone to call, you are generating data. Each time you go to WhatsApp, you are using Skype. You are going to internet, you are generating data. That's what we call the clickstream. What is clickstream? Each time you go to a certain website, each time you click on a link, it is recorded. All these activities are recorded. So you may not know, but you are participating to the big data. So then secondly, all your web activities, your devices, even healthcare appliances, which we call the internet, the Internet of Things, which are small objects that connect to the internet, they generate data that is going over the cloud you may not even know. So you are part of the big data. When you do credit card transactions, all these data are recorded. So you are generating smartphone, etc. And also big data can affect your privacy. And one of the most recent issues about privacy and big data is the GDPR, which is General Data Protection Regulation, which is given by the European Union. And I put the link there so you get it. So big data also big data and data science can work for your advantage. And that's what I want to have. My time is almost up, but it's okay. So big data has been used to help us. For example, in what we call fraud detection, for example, you can use, if you have a credit card, and one day it happens, I was using Prof credit card, and then we did like 4 transactions. And then suddenly, the card was blocked. But why was it blocked? Because each time Prof uses his credit card, it is recorded. And there is a model of the uses he makes of his credit card. So if you are used to use it maybe once per week or in average 5 times per month, and suddenly in one day you are doing 10 transactions, then it raises alarms. So it helps us to protect your properties. Data, one of the interesting parallel that somebody has made is one of the pioneers in data science. His name is Kirill Minko. He made a parallel between big data and what we call the Maslow's hierarchy of needs. So to remember, if you have lost a bit of your psychology, Maslow's hierarchy of needs is what you have here. Since my time is up, I will not go into the detail, but you know this, just to remind you. But now, how can big data help to achieve those needs? That's what I just want to, a few times I will take to present that. So remember one thing, there's a general saying that what you can't measure, you can't improve it. If you can't measure something, you can't improve it. Big data can help in the physiological needs. What is the physiological need? The need for food, the need for shelter, the need for, these are the physiological needs in the Maslow's hierarchy. So data has been used to reduce, for example, pollution in the air, and then improve the overall living condition of human beings. I don't have the time to go into the details, but there are a number of projects, especially IBM is working very hard in that area, where big data is used really to improve life of people. Also, food security is one area where big data actually is participating. Next, big data can help to achieve safety, the safety needs. Today, medicine is one of the most prominent discipline in which data science is making its mark. Data is gathered and used to inform diagnostics, recommend different practical approaches, and build new products. So machine learning is used to use the data in the most accurate way. So for example, today we have an app. You can use your smartphone and scan and see if you have a certain kind of cancer using that application, which is the artificial intelligence application called skin vision that you can use, and so on. Big data can also be used to meet our social needs. Today, the success of what we call social networks, such as Facebook, Instagram, LinkedIn, and so on, is not because of their platforms, it's because of the data they generate. It's the data that is so. Today, you can find your old friends, school friends, by going into the internet. Scholars and practitioners can find people with the same profile who are interested in the same project, and they can partner together and work together. Today we have what we call the recommendation systems. You can find easily a job over the internet by a proper definition of your profile. So these are some of the ways the big data is helping. When you put your picture over the internet, the social network can connect directly that picture to a lot of other information, relate them. So this linking is what we are doing. So we can have a social over through big data. Then big data and esteem with the rise. If you go today, if you are familiar to online programs, it could be short courses online. There are so many now. Most of those programs, as you enroll there, they ask you to rate the program. As you go, you finish one chapter, second chapter, they ask you to rate the program. Or if you are doing support lines, they will, after you have used the support line, they ask you to rate the service. So this rating system generates an amount of big data that can help people to know that they are doing well or they are not doing well. So that will help them to satisfy the esteem needs. And also, in terms of the last level of the Maslow hierarchy is self-actualization. And in that area, today there's what we call virtual reality. That is using computer system to generate an artificial environment where somebody can find himself and escape this world of sin, this world of difficulties. We can escape it and go into a virtual world and have this kind of satisfaction that is out of what we call the deficiency need, because when you are self-actualization, now you want to go a higher ground. So you can be in a kind of nirvana through virtual reality. So what am I saying this morning? This morning I'm just saying, okay, big data is 3 B's. It is big, it is acquired at a very high speed, velocity, and it is varied, and then big data has generated a new discipline which is called data science, and big data is important for you because you are part of the big data. You generate the big data, and then you can use the big data. Even you can use the big data to climb the Maslow's levels of need, hierarchy of need. And in your career, with a little creativity, you can really be innovative using big data. Thank you so much for your attention. Now your questions and comments. I don't know if I still have time.
Thank you very much. Let's appreciate